way. What if I have some graphs of parent functions and I want to see how to do a vertical stretch or shrink in those cases when I don't necessarily know the ordered pairs? Well, I dealt with x squared yesterday. Let's look at f of x equals the negative 2 absolute value x minus 4. So first of all, let's make sure we're dealing with that negative in front and that 2 in front as two separate transformations. Yesterday, we said a negative out in front of a function reflects something over the x-axis. So this is reflected over the x-axis. Now let's address the 2. 2 is what we just learned from today. 2 out in front of the function is a vertical stretch of 2. And then from yesterday, if I have x minus 4 inside the parentheses or inside the function, that moves the function right 4. So now I'm going to graph the most basic absolute value function from the ones we memorized. I'm going to just do this as a dashed graph. Some notes about the absolute value function, some kind of key points when I'm sketching my new graph, is it goes through the point 0, 0, 1, 1, negative 1, 1, and it's a V shape. All right, so I'm going to just do some graphs with some other colors. I'm going to make them dashed till I get to my final one. To reflect over the x-axis, instead of going up, we would go down. So it would look like this instead. Okay. And so if those are kind of my new 3 key points. If I vertically stretched by 2, what it would do is it'd take the y values and it would multiply them by 2. So this point here that was down negative 1, that would be down negative 2 now. Okay, so I'm going to go a different color yet again. So now, stretch, now it looks like this. Just trying to do my progression. You don't have to do this every time. I'm trying to show my thought process. Finally, I would move right 4. So if I would take this whole graph and move it to the right 4, then now I'm going to draw my final graph. That means my vertex would be at 4, 0, and then I go over 1, down 2. Looks, this would be my final graph. Okay, it's vertically pulled, kind of makes it narrower, and then it's flipped over and it's moved right 4. So that's kind of the idea when you're doing the basic function x squared. Things with x squared would be similar. My expectation on homework is, would you draw your original and your final graph? Okay. Finally, let's talk about the order in which transformations occur. In general, on transformations, you may go from left to right. So you can address this 3, then this 1, then this 6. The only exception is when you have double transformations inside the parentheses, you want to flip those around because x is a liar, and you'd want to do this first followed by that. In this case, you're going to notice I don't have that in any of these, so we're going to address from left to right, and then our order will be correct and match what you would see on a graph. I'm not going to graph them on my graphing calculator. You are welcome to. So first of all, what basic function is a related to? Well, it's related to the basic function x squared. What does this 3 do? A 3 out in front is a vertical stretch of 3. That would occur first. Replacing x with x minus 1 moves our graph right 1. And subtracting 6 off the back of my function moves the function down 6. Okay, so let's go to another function. Hopefully you see there is a square root involved here. So this one is related to the square root of x. I'm going to go from left to right. Negative, just the negative. Do not think of this as a negative 0.5. It's separate. And the negative in front is a reflection over the x-axis. A 0.5 in front, 0.5 in front. We treat it and we leave the 0.5 the same. Multiplying y values by 0.5 would be a vertical compression of 0.5. Replacing x with x plus 4 finally would move the graph left 4. All right, I wanted to look at a couple of horizontal shrinks or compressions and stretches. So I'm going to address that first. This 4 right here, when we're talking about 4x and the number is inside the parentheses, I take that 4 and to figure out what happens, I take the reciprocal. The reciprocal of that is 1/4. If I multiply by something that's 1/4, that is a compression. So that 4 really means a horizontal compression of 1/4. Then subtracting 4 off the back really means moving the graph down 4. Let's take a look at what a horizontal stretch looks like. Sometimes I tell students, if it helps you, to rewrite this as instead of x over 3, it might help you to rewrite that as 1/3 x. I don't know if it does or not. I'm just giving you some suggestions. Why that's helpful to me is then when I'm identifying this number in front, if it's with x, I always take the reciprocal. And what that tells me is the factor that I'm multiplying by is not 1/3, it's the reciprocal of 1/3 or 3. And when I multiply by 3, that makes something bigger. So this is going to be a stretch, not a compression. Let's go from left to right. We have a negative in front. That is a reflection over the x-axis. As I just talked through, I take the reciprocal of 1/3. It's 3. That makes this a horizontal stretch of 3. And subtracting 2 off the back would shift down 2. Okay, I know there's a lot to digest in here. I hope I've given you enough examples to get your problem set done. We can talk about some of these things and clean up some of these things tomorrow in class. But check the calendar or do the problems listed on the front board.